Good morning, everyone. How's it going? Today, our lesson is about carbonyl compounds. Carbonyl compounds, they are classified into two main groups, aldehydes and ketone. And I will start talking about aldehydes. All right. Aldehydes, they are organic compounds with carbonyl group. Okay, what's the meaning of carbonyl group? It's carbon atom that is bonded to in a double bond to oxygen. So this is carbonyl group. And it will be attached to a hydrogen atom at the end of the chain. Okay? At the end of the chain, you can see the carbonyl with hydrogen atom, so you can say it's an aldehyde. Okay, how can I name any aldehyde? I will start counting the carbon atoms in order to find what? The longest chain. But my starting point from carbonyl here. Okay, so I will start from carbonyl and the name will be different from alkane into it will be replaced by alkanal. So it will be methanal, ethanal. And guys, no need to mention the number of carbonyl group as it's always located at the end of the chain. Okay, so it could be methanal, ethanal, let's say 4-methyl propanal, like this. Okay, and we will take examples later on. Okay, preparation of aldehydes. How can I prepare any aldehyde? I need what? Primary alcohol. What's the meaning of primary alcohol? It's an alcohol that is the carbon holding the hydroxyl group. It's attached to one carbon atom. I will add to it that O. What's the meaning of that O? We took it before. It's oxidizing agent. So I will add oxidizing agent to my primary alcohols and I can produce my aldehyde plus H2O. The type of that chemical reaction is oxidation of primary alcohol and reagent and conditions for that reaction. Let's start thinking about it. I need to warm my alcohol. First of all, I will add a drop of that potassium dichromate, which is my oxidizing agent here. Okay, and it has orange color. That orange color, after doing its role in oxidation, it will be changed into green color, and we can see changing on the oxidation state for chromium from +6 to +3. It means it has been reduced. Okay, so my oxidizing agent, it will do oxidation for the primary alcohol while being reduced. Okay, this aldehyde, it has lower boiling point as the intermolecular force for it is different. What's the difference between the intermolecular force for that aldehyde from other constituent in our chemical reaction? Here we have OH. So the intermolecular force here is hydrogen bonding, and here also it's hydrogen bonding, while here we have permanent dipole. Okay, so the difference in the boiling point, it will give me a chance to do distillation in order to separate my aldehyde. Okay, let's assume we do a further heating for my mixture. I will do further oxidation. Further oxidation will produce carboxylic acid from that aldehyde. So that aldehyde, by further oxidation, we will prepare carboxylic acid. Let's go for ketone. Ketone, it's organic compound and it's an isomer with our aldehyde if we have the same number of carbon atoms. And that ketone will be attached to two alkyl groups from the left and from the right in order to be a ketone. To name it, I will start numbering the chain from the nearest side to my carbonyl as it's located inside the chain, okay? And the name will be alkanone. Let's take an example here. This compound, is it aldehyde or ketone? It's ketone, yes. I will start numbering it from this carbon, CH3, then the carbonyl, then carbon, CH2, then CH3, and it's what? It's 2. You have to state the number for carbonyl. 2-butanone. 2-butanone. That's correct. Okay, let's go to the next compound. Also, it's what? It's ketone, and you can see here ketone, the carbonyl, it's located on carbon 3 and we have a substituent. So what will be the name for that compound? We have 6 carbon atoms. Hexanone, and it's 3-hexanone as the carbonyl, it's carbon number 3. And we have 4-methyl. So 4-methyl 3-hexanone. Let's see that compound. In that compound, I have changed the formula in a way to see how can I write the aldehyde. It's an aldehyde, guys, but in a different way. We can write it CHO. So this O is related to the carbon atom here, okay? And we can name it, and I will start from the carbonyl. So 1, 2 carbon atoms, it's ethanol. Okay, let's see the next formula. Here we have different type of formula. It's a skeletal formula, and we can see here the carbonyl, it's located at the end of the chain. So it's what? It's aldehyde. So 5 carbon atoms, pentanal. Yes, pentanal. Okay. So this is an exercise how to name different structures of carbonyl compounds. Let's see how can I prepare a ketone. Here also we have the same style of preparation of aldehyde. I will start with secondary, not primary. Secondary alcohol and oxidizing agent will be added. It's also acidified potassium dichromate, and it will give me ketone plus H2O. The type of that chemical reaction is what? Oxidation of secondary alcohol, and the reagent here is heating. Here the condition, it's acidified potassium dichromate. Here the difference, no need to distill off the ketone. Why? There is no further oxidation like aldehyde. In aldehyde, further oxidation, it will continue the oxidation to prepare what? To prepare the carboxylic acid. Here, I can prepare my ketone easily. Okay, let's do the opposite of oxidation for aldehydes and ketone. The opposite, it's reduction. So, by reducing the aldehyde, I will prepare what? Primary alcohol. It's the original compound. We start from it in order to prepare the aldehyde. So the opposite will give me also the original one. So aldehyde with reducing agent, I will refer it back to my primary alcohol. Also ketone, I will take it back to my original compound, which is secondary alcohol. We have two options for reagents. If we do warming for my aldehyde, I will use sodium tetrahydroidoborate, and it's aqueous solution, so it's dissolved in water. Okay, so reducing agent here, it's done with heating. Okay, you have to memorize it, guys. The other option, at room temperature, we can use lithium tetrahydroido, the same thing, aluminate, but in this case we will dissolve it in dry ether. Okay, lithium will be dissolved in dry ether, because if this reagent is dissolved in water, it will be a vigorous reaction. So dry ether, it's more suitable solvent for that reagent. Okay, that's the first lecture. That is the first lecture. Hopefully you understand all of the points, and you can contact me for any question, guys. Stay safe, and we'll continue in the next video on other reactions for those carbonyl compounds. Thank you.